Good morning, 5th and 6th period Algebra 1. What we've got for you today is just a little treat. I want to look at a couple problems from today's homework. So what this is this is the page between the radicals number 3 and the radicals number 4. And let's just make that word of the day is radical. Of course, we've got our radical sign. Also called a square root sign. We didn't get to do this in class because, of course, class was canceled. But the root of that word is how we say something is cool. Maybe back in the 90s, we would say it is rad. So word of the day is rad. Go ahead and use that as many times as absolutely possible today. So I'm looking first at problem number 16 here. And I've got a couple things going on. I've got 5 times the square root of 98 a to the 20th b to the 3rd. So now we've got 3 different things under the radical sign. I've got a numeric part, and then I have 2 different variables. I have an a, I have a b. So, and then of course this 5 is just going to kind of follow along with us here for a little while. And the first thing I like to do is break this radical into these 3 parts. This is your product rule for radicals that allows us to do this. We're going to say radical 98, and then we'll have our a to the 20th, and then we'll have our b to the 3rd. So then we can just deal with these now 4 pieces individually. So I've got my 5, and maybe I'll switch colors here. The square root of 98. Now if I get stuck here, I'm thinking of a perfect square factor that goes into 98 evenly. Now, what I mean by a perfect square factor is these perfect squares that we talked about in the previous video. Any number on this side is a perfect square. And the one I see here that works really nicely is 49. 49 goes into 98 evenly. So we'll actually break this 98 apart into 49 times 2. We could probably just go ahead and deal with this one. Again, a to the 20th. The square root of that is a to the 10th. Maybe another way to think about that is a to the 10th times itself is a to the 20th. Or that radical is just a 1/2 exponent. The b part, we talked about this Friday. If this exponent is odd, we cannot divide it by 2. We have to, I like to think of it as just subtracting 1 from that exponent and writing it as b squared times b. Okay? My next step of work, again, I'm not quite ready to do anything with this 5. We're going to use our product rule again. The square root of 49 times the square root of 2, a to the 10th, the square root of b squared times the square root of b. And now we're ready to evaluate a couple of these radicals. I have 5 times the square root of 49 is just the number 7 times the square root of 2 times a to the 10th. The square root of b squared is, that's just b. And then we have just the square root of b. So we've simplified every part of this radical. Don't forget, we have to reorder things now. Okay, I want the numeric part first. 5 times 7, which is 35. And then I want the variables in alphabetical order. So a to the 10th, b. So we did a to the 10th, then we did b. And then we have 2 different radical parts. And we can use the product rule again to put them back together as one. The radical of 2b. Or not to be. That is the question.